Okay, so you should be on video 2 of 2. I'm hoping this is just 2 videos. Looking at number 3, we have e to the x minus 1 all over x squared minus 2x plus 1. And what happens here when we plug in 1, we get 1 minus 1, which is 0. So it's going to result in, let me get my pen. 0 in the numerator, and if we plug in 1 in the denominator, we also get 0. Okay, so which is an indeterminate form. Therefore, L'Hopital's applies. Okay, so what we're going to do is we're going to take the derivative of our numerator, the derivative of our denominator, and then evaluate that limit. So I want you to pause the video, go ahead and find the derivative of our numerator, find the derivative of our denominator, and then do direct substitution. So there's our derivative. Now go ahead and do direct substitution with the 1. So what we end up getting is 1 divided by 0, and we know that that's telling us that we have a vertical asymptote at 1. So therefore this is dne, and the way to check what's happening there is by plugging in, doing left and right side limits for 1. So if you look at 1 from the left hand side, so even just when you're doing that, to give your reason of why it does not exist, if you are looking right here and you plug in 1 from the left, that's going to give you a 1 divided by a 0 from the negative, which is a negative infinity. And if you plug in a 1 with a plus sign, then you would end up getting 1 divided by 0 from the positive, which is going to give you positive infinity. So the reason that this doesn't exist, because the limit as x approaches 1 from the left doesn't equal the limit as x approaches 1 from the right. Okay? Okay, go ahead and take a look at number 4. Actually, go ahead and just try both of these, 4 and 5. So pause this, plug in 0 for 4, 1 into 5, see what you get. If you get indeterminate form, therefore L'Hopital's applies, and you will do the limit of the derivative of our numerator over the derivative of our denominator. So for 4, you plug in 0, you get 0 over 0, which is an indeterminate form. Therefore, L'Hopital's applies. So do your derivative of x cubed, which is 3x squared. Derivative of the natural log of x plus 1 is just 1 over x plus 1 times the derivative of x plus 1, which is just 1. And now you plug in and see what happens. When you do that, you end up getting 0 over 1, which that just equals 0. Okay, so not too bad. When you looked at number 5, you got 0 over 1, which is not an indeterminate form. So actually direct substitution does work. So don't just assume just because these are all mixed in, this is what you think you need to do every time. So in this case, you get 0 over the square root of 1, which is 1. So our answer again here is 0. Okay, L'Hopital's doesn't apply. The answer is 0. Okay, so you don't need to use it. Okay, and this last one we're going to do together. We have the limit as x approaches negative infinity of x squared over e to the negative x. Okay, and again, going back to limits and thinking about limits and what's happening here, think about your end behavior. Okay, when you plug in negative infinity and square it, where's your end behavior of that quadratic? It's going to positive infinity. Think about this. e to the x is growth, e to the negative x is decay. So what's happening as x gets closer to negative infinity, your y value gets closer to positive infinity. Okay, so don't forget those visuals that can help you kind of think about what you have going on here. So since this results in infinity over infinity, which is an indeterminate form, we will go ahead and do our derivative of our numerator and our derivative of our denominator, and evaluate that limit as x approaches negative infinity. Okay, so our derivative of x squared is 2x. Our derivative of e to the negative x is just e to the negative x times the derivative of negative x, which is negative 1. And we can rewrite that quick as a negative 2x all over e to the negative x. So again, think about when you're plugging in negative infinity, what's happening? This right here, that's just a line. So as x gets closer to negative infinity, you can clearly see your y is going to positive. And e to the negative x, same thing. That's also going to positive. So guess what? We have the same thing. And this is an example where L'Hopital's can be applied again. So you will take your derivative of your numerator, which is negative 2, divided by our derivative of our denominator, which is e to the negative x times negative 1 again, and really that just becomes 2 over e to the negative x. So what does that give us? It results in 2 over e to the negative x. When we plug in a negative infinity, we get 2 over infinity. And 2 divided by a really large number, what does that give us? 0. Okay, I will give you one more to try on your own if you would like to. And if you don't and you feel like you're good to go, then go ahead and get started on the rest of the work for the day. But this one is the limit as x approaches negative infinity of 3x squared plus 6 all over 4x cubed minus 3x. So I want you to go ahead and just try that. Give that a try. See how many times you have to use L'Hopital's rule, okay? And then check back in. So pause your video. Okay, so for this one, you apply L'Hopital's rule twice. So the first time when you plug it in, you get positive infinity divided by negative infinity. So you do the derivative of the numerator, derivative of the denominator, plug back in negative infinity, and that results in negative infinity over positive, again, an indeterminate form. So we do our derivative again, which gives us 6 times 24x. And when we plug that in, you get 6 divided by negative infinity. So remember, 6 divided by this really, really large negative number is pretty much just going to give us 0. Okay, so that is it, and you are all set, and that is it. We are going to work tomorrow on Khan Academy with L'Hopital's, so we are still going to spend 2 days on it just to get some good practice on it. Make sure you guys have it set before we start with the review next week. Okay? All right, have a good day.